All right, as promised, we will go through another key for the Hydrosphere bonding review POGL. And hopefully you noticed that you really don't want to start with Model 1. You want to go down and start with Question 1. And then you can move on to Model 1 from there. So the symbols P, P plus and naught and E minus stand for protons, neutrons, and electrons, respectively. And the little superscript symbol tells you their charge. So protons and neutrons are in the nucleus, and electrons are in the electron cloud surrounding the nucleus. So if you want to know how many protons are in an atom, you should look at your very best friend, the periodic table. And it is the whole number. And so that's how we can find out the number of protons. How do we know the number of electrons? Well, typically, protons equals electrons, unless it's an ion. But in this model, we're really not interested in ions. We're really just looking at atoms. So what does the number in the atomic symbol stand for? So we have like H-1 or L-7, and that number is the mass number. And that is equal to the protons plus the number of neutrons in the nucleus. So if you want to figure out how many neutrons something has, neutrons is equal to mass number minus the number of protons. Okay. All right. So now, if we look back at Model 1, we have two models that are completed for us, and we want to compare the Bohr models. We're not going to compare other things right now, but we're just looking at our Bohr models. So this Bohr model, we have a very simple model. So we have 1 over 1 and then H. So the one on the top tells me the mass number, the one on the bottom tells me the atomic number, and then it has the atomic symbol. So I would know where to look for this on the periodic table. And then it shows us the electrons. We've got one ring with one electron. Magnesium is more complicated. So we have magnesium's atomic symbol, its atomic number is 12, and then its mass number is 24. And it shows that there are 2 electrons on the first ring, and then 8 electrons on the second ring, and then 2 electrons on the last ring. So these are similar because they both have rings with electrons. They're similar because they both have this atomic symbol with the atomic number and mass number on it. But they're different because they have different symbols, different mass and atomic numbers, and different numbers of electrons, and because they have different electrons, they have different rings as well. So the next question just asks us to finish filling out this table based on number 1, which is already completed, and number 24, magnesium, which is partially completed, and then I'll do one more example in addition to that. And then I'm just going to pause the video, make the key, and then that way the key is accessible to you. So for magnesium, we would write its name. You could find it on the periodic table using either the symbol Mg or the atomic number. We know protons is equal to the atomic number. So, gosh, I wish it would stop doing that. I don't know how to fix it though. Oh geez, okay, that's a little too giant. Okay, that's better. So then our protons are 12. And then to get our neutrons, we'll do 24, the mass number, minus 12 equals, in this case, 12. So in this instance, the neutrons and protons are the same. To find my number of electrons, I can just count my electrons. So I have 2 plus 8 is 10, plus 2 more is 12. And my valence electrons, my outermost electrons, they're on this outside ring. And so I have 2 of those. Okay, I'm going to pick one more for y'all. Let's see, maybe, let's look at chlorine. So chlorine is number 35, and so we can write its name based on the periodic table. It is number 17. I'm pretty sure somebody stole my chemistry book off of my desk. Hold, please. Good news, you guys. I found it. It is number 17. Chlorine is number 17. So 17 protons. We'll do 35 minus 17 to get 18 neutrons. And then for our electrons, because there's no charge, this is neutral, my protons are always going to be equal to my electrons in this example. So I have 17 electrons. Then I need to draw my Bohr model to figure out my valence electrons. So I've got my 35, 17, chlorine, little circle. It's 1 valence electron, 2, another ring, put 8 on this one, 1, 2, 3, 4, 5, 6, 7, 8. So now I have 10. So I only need 7 more. So I've got 1 more ring. And so I just fill in that last ring with the 7 electrons I needed. And now I have a complete Bohr model. Okay, I'm going to pause the video right now and complete making this key. And we'll pick back up in a minute. Okay, so I finished out my key, and it's a little bit messy, sorry about that. But you can see all of the names and the values for protons, neutrons, and electrons, and valence electrons. I drew the Bohr models. They're a little bit ugly, but hopefully they help you check your work. Okay, so now we're going to move on to model 2, which is bonding. So the subatomic particles active in bonding are the electrons, and specifically, sorry about that, specifically the valence electrons are involved. Why do atoms form bonds? They want to have a complete octet. So they want to have 8 valence electrons. Three types of bonding. Metallic, which is a sea of shared electrons. There's ionic, which is electrons are transferred from one atom to another. And covalent, which is electrons are shared between atoms. All right, so then this next section, go ahead and try to predict if they will gain or lose or share electrons. So to do this, we really want to think about, is it easier to get to 8 by giving away electrons, or is it easier to get to 8 by gaining electrons? So if we scroll back up here, I'm just going to write a G or an L for gain or lose. So hydrogen is kind of like, it could go either way, but typically typically it loses one, and it has a positive charge. So typically hydrogen loses. Lithium wants to lose one. So you look at this little sad valence electron by itself. It wants to lose. Beryllium wants to lose. Magnesium only has 2 valence electrons, so it probably loses. Aluminum loses because it's easier to get rid of 3 than it is to gain 5 electrons. Carbon could go either way, so it could gain or lose because it's 4. Nitrogen probably gains because it's 5. Silicon, again, could gain or lose. Oxygen definitely gains. Chlorine also definitely gains because it's super close to 8 valence electrons. So thinking back to things we talked about last week, what is a cation? Cation is a positively charged atom. And an anion is a negatively charged atom. So if you lose valence electrons, you're going to become a cation. You're going to be positive. If you gain valence electrons, you're going to be an anion. So who forms ionic bonds? It's going to be a metal plus a nonmetal. Covalent bonds are nonmetal, nonmetal. And metallic is all metals. So now, last thing to do is identify these as metallic, ionic, or covalent. So aluminum and oxygen is going to be ionic. So first you should identify them as a metal or a nonmetal, and then that'll allow you to identify what kind of bond. So carbon is a nonmetal, and so is fluorine, so that's definitely going to be covalent. Potassium is a metal, sulfur is a nonmetal, so that's ionic. Carbon and hydrogen are both nonmetals, so that's covalent. 2 metals is metallic. Metal and a nonmetal is ionic. Metal and a metal is metallic. Metal, nonmetal, ionic. Non-metal, nonmetal, covalent. Non-metal, nonmetal is also covalent. That's non-metal, nonmetal, that's going to be covalent. And then molybdenum and zirconium, those are both metals, so that's metallic. All right, you guys, hopefully that was helpful. Looking forward to a good week. Keep giving me feedback so that I can be more effective at helping you guys. Love you guys, and hopefully I will see your sweet faces soon.